All right, section 13.2, we talked about pressure in the last chapter. What we're going to talk about now are some common terms or ideas that occur with pressure. And the first one is Pascal's principle. Only fitting that Pascal is our unit. He also came up with the principle. So Pascal was busy working with pressure. And what Pascal says is that how do we transmit pressure in a fluid? And Pascal says a fluid exerts pressure equally in all directions at any given depth, which means that no matter where you are, the pressure is exerted equally. It's not greater in one spot, it's equal throughout your entire body. So if you think of like a deep sea diver, when he keeps diving down, the pressure on his body is equal over the course of his entire body. Right, so it's equal over the course of his entire body. Or an astronaut in outer space, the pressure is equal over the force of his entire body. It's not greater in one single spot. Now, the amount of pressure exerted by a fluid depends on the type of fluid and its depth. So what that means is if I was a deep sea diver, diving in a sea full of ketchup, it would act differently than it would be water. Also, the deeper I go, the more pressure I'm going to have exerted on me, which we're going to talk about. And if we're going to put Pascal's principle into words, all right, in a full definition, a change in pressure at any point is transmitted equally. What you need to know about Pascal's principle is that pressure is distributed equally over every part of the object. That's Pascal's principle. All right. Next up, we have Bernoulli's principle. All right, a Swiss scientist, Daniel Bernoulli, stated as the speed of a fluid increases, the pressure decreases. How the heck does this work? Well, let's talk about this. There are two common examples which are really, really key here. As the speed of a fluid increases, the pressure decreases. Guys, this is how an airplane works. This is how airplanes create lift. If you think of a wing looks like this. All right, kind of like that. When the air is coming here, it splits, and some of it goes over the wing, and some of it goes under the wing. The cool thing about when the air splits is it's going to meet exactly at the same point on the end of the wing. Now, which one is it going to take longer to go over, the top or the bottom? Think about this. Which one's it going to take longer to go over? It's going to take longer to go over the top. Right? Well, if it's going to take longer to go over the top, the speed on the air on the top has to be faster. Well, if we follow Bernoulli's principle, as the speed of a fluid increases, which is what it's doing on the top of the wing, the pressure decreases. Well, what's going to happen here? We're going to have low pressure on top of the wing, greater pressure underneath the wing, and what's going to happen? It's going to create lift. Right. Here's another example. Right. You guys ever, you're ever showering and all of a sudden the curtain feels like it's sticking to you? So you're sitting in the shower, right? Now what's happening? All right. You have the shower on. Right. Well, the shower is usually warm, right? Well, what's that doing? As you're warming the air, you're increasing, right? The speed of the air increases. So if this is you and this is the shower curtain, what's going to happen? What's going to happen inside the shower? Because you're warming up the air, the fluid is going faster, so you're going to have low pressure on the inside of the shower curtain where you're showering and high on the outside. Well, what's that high pressure going to do? It's going to push in, and your shower curtain is going to pretend like it's sticking to you. All right? One last example of Bernoulli's principle at work. You ever been driving down the highway with your parents or riding down the highway with your parents and you pass a semi and you feel like you get sucked into the semi? Well, let's talk about what's happening on the highway here. We got a huge semi here and a car right here. Okay. Now, you're pushing through the air, right? You're pushing through the air. So what happens as you're pushing through the air? You are increasing. You are increasing the air. So between the two vehicles here, there's a lot of air moving because it's a two-lane highway and you're very close together. Well, remember, as the speed of a fluid increases, the pressure decreases. So in between the cars, there's low pressure. On the outside, there is no movement of air, or not nearly as much as there is in between the cars, and the high pressure is going to push in on you, and it's going to feel like you're getting sucked closer to the vehicle. Now, it's a small effect, but it's just another example of how Bernoulli's principle works. So remember, Bernoulli's principle: as the speed of a fluid increases, the pressure of the fluid decreases. We have airplanes, we have the shower curtain sticking to you, and you have, when you're driving down the highway in a two-lane highway, if you feel like you're getting sucked closer to a semi, that's all Bernoulli's principle. Right. Last thing that we need to talk about is buoyancy. And buoyancy is the upward force in a fluid. So it's the upward force in a fluid. So if you're going to get this, it's the ability of a fluid to exert an upward force. This is going to be, if the buoyant force is enough, all right, this is going to be deemed as floating. This is kind of why an object floats, because the liquid is applying a force to whatever is in it. Now, if you're not floating, like for example, the human body really doesn't float in water, all right? You have to work, right? If you are in water for 10 hours, you drown. It just doesn't naturally float. So, but what happens is this: have you ever gotten out of the pool on the steps, and each step you get out, you feel heavier and heavier? That's because the apparent weight. While you're in the pool, the water, the buoyant force of the water is pushing up on you, which makes you feel lighter than if you are outside just on the ground. So buoyant force is the upward force in a fluid. If that force, upward force, is really great, an object will float. So this is why things have the ability to float, is buoyancy. So buoyancy is the ability of a fluid to exert an upward force on an object. This will conclude section 13.2.